right, so now it's time after these last two videos to finally algebraically find a limit. And it's gonna be really tedious at first, but as we build up more kind of tools as we go in practice, we'll be able to do these faster. But right now, all we have is those limit laws and limit properties. All right, so use the limit laws to evaluate the limit of, I should have put parentheses around this. All right, the whole thing, 4x plus 2. All right, so we kind of have two different things going on in our limit. We have this 4 and this 2, and we kind of want to get things down to just a single x, because just a single x from that video, 2 videos ago, we can figure out just the limit of x. So the first thing I can do is using the sum and difference identity. I have a plus sign here, so I can break this up into 2 different limits. That's exactly what the sum and difference said. If I was adding 2 things in the limit, I break it up into 2 different limits with those pieces. Right. This right-hand side is already where we want to go because we have a limit of just some constant number. That is something that we learned in that second video. Here we still have a little bit more. That's not just a single x, but we do have, this is actually the example I used in that video, so we have 4x. This 4 can jump out in front of the limit. So we have the 4 there, and the limit, oops, wrong thing. There's just an x there now. I don't know why it won't let me erase this. So I'm just going to write over it. And there's an x there. All right, so now we have these 2 limits with the exact things we had from the second video. We have a limit with x and a limit with a constant. And our rules say, well, this 4 is just going to stay around. But our thing says we had an x here. This 3 just gets plugged in there. And if we had a constant limit, our answer was just a constant. And now we can simplify. 4 times 3 is 12, plus 2 is 14. All right, so our final answer is 14. All right, so the limit as x approaches 3 of 4x plus 2 is 14. So that function should be 14 when x is 3. Again, it's going to be a little tedious from now, and we'll probably get tired of it when we do the practice in class. All right, but we kind of have to see how these limit laws work. All right, so again, just kind of breaking it down step by step. The first thing is we have this big division bar in the middle of this problem. So what I can do is break this up into 2 different limits, one on the top and one on the bottom. And then on the top, we have a plus sign. On the bottom, we have a minus sign. So that means we can break it up into separate limits on the top and bottom. You're going to write the little lim part a lot while you're doing all this. The bottom's good because we have just a limit with just an x and just a limit with a constant. So those are done, but we can still do a bit more with the top. All right. We saw that with exponents, we can put the exponent around the limit. So I can do the limit of x and then square all that. So that was our power rule. This other one with 2x, 2 is just like the 4 in the previous example. That becomes that constant out in front. And the bottom we'll just leave the same because we can't do anything else to those limits. And what we always want to get to is where we have the limit with just an x or just some constant number. So once you get there, you're done in terms of breaking this down, and now you can actually apply the rules. All right, the limit as x approaches 1 of x is going to be 1, and that's going to be squared. All right, plus 2 times 1, that limits 1, and that limits 7. All right, so just using those 2 initial rules we learned, and now it's just simplifying. And we'll get -1/2 as our final answer. Again, as long as that bottom doesn't turn out to be 0, it's good. If the bottom turned out to be 0, that's a whole nother issue we'll talk about later. I prefer this one. Everything works out fine. No problems with division. And for this last one, you can kind of decide if you want to watch this example or not. If you still kind of want to see how these limits are breaking up, watch it. All right, but you might kind of understand what's happening after those first two examples. All right, but if you want to see this one, all right, go ahead and keep watching. So again, we have this big plus sign in the middle. So that tells me I'm going to break it up into two separate limits that are being added together. All right, one thing that students tend to do is just get a little lazy. Make sure you actually write that limit part every single time because you're taking the limit, kind of breaking it up. All right, next, just like the previous example, I can move that exponent to the outside. We haven't done this one yet, but we also saw that square roots and kind of move the square root outside and the limit inside. And then that first part's good. This part's good because it's just an x. Here we still have a 4x, so I have to do the constant multiple. So this first part's going to stay the same. Set square roots on the outside, but then inside of that square root, this 4 is going to jump out in front of that limit. Oops, not 4x, just x. I don't know why that's not. Let me erase that. All right, well, this is an easy fix. It's just x. But now again, we're down to what we want. When it's just a limit of x, we just basically plug in whatever the a value is for x. So it's going to be 4 squared plus the square root of that 4 is coming from the 4 that's already there. And then the limit part is also a 4. And then again, it's just simplifying after that. We get our final answer of 20. All right, so if you watch all 3 of these examples, you might kind of start to see a pattern, and we'll kind of keep going with that when we do the examples in class. But right now, if we're trying to figure out a limit algebraically, we have to break it up into its smallest pieces until we get down to limits with just the x or limits with some constant. All right, so that's what we did here. Got those two limits with an x, and then we can actually evaluate using those limit properties. But really shortly, we'll have other ways to do this as we kind of build up what we know about limits.